So we are continuing the solution for solves plus for the Kinematics Momentum paper 1. Today we are doing 2.3, which is the projectile segment. And yeah, so this is question number 10. The question reads: two markers M1 and M2 are set up a vertical distance h apart. A steel ball is released at time 0 from a distance x above M1. The ball reaches M1 at time t1 and reaches M2 at time t2. The acceleration of the ball is constant. Which expression gives the acceleration of the ball? Okay, we can pretty well solve this problem. This is not a very difficult problem, but the main confusion that many of the kids actually go through is that they misread the description and also misunderstand the labeling of this figure. Have a look at this figure, and what you need to understand that we dropped the ball from this position. After falling a vertical height of x, the time passed by was t1, which is easy to understand. After passing a further h height, the time recorded was t2. So this t2 is not the exclusive time requirement to fall by a height of h. T2 is the time starting from 0 all the way up to this level, which means in a time of t2, within the duration of time t2, the vertical height fallen by the steel ball was not h, it was x plus h. So let's say this was 0 second, this was 2 second, and let's say this was 4 second, not 4. Let's say this was 10 second. So within this time you have 2 seconds, within this time you have 8 seconds. This t2 is t2 starting from 0 over here. And within this t2 time, the entire height that the steel ball went through was x plus h, the entire of it. So if we understand that much, then solving this problem becomes much too simpler. Question says, which expression gives the acceleration of the ball? So did we start it from release it from rest? Steel ball is released at time 0. Okay, release to essentially initial velocity is 0. So if I go for equation build up, for the first part, x equals to 0 into t1 plus half a t1 squared. For the second part, x plus h equals to 0 into t2 plus half a t2 squared. Check this out. See if you can agree with these two equations. If you can, then the rest of the part is pretty simple. You just have to find out the value of a in terms of h, t2, and t1. So a simple process can be replace the value of x from this equation. If we go for this equation, we can subject x equals to how much? Get rid of this part. Okay, I don't have to write this actually. I can necessarily erase this part. So 0 to t1 is not needed. So x equals to half a t1 squared. Replace this over here. Then subject a from this entire expression. And ultimately you will be left with D, I believe. Not C. Calculation করে দেখো. I don't want to write this whole calculation. You do this on your own. Use your copy, use your brain and pencil. I believe you have all three of those.
Sir, yes, sir. D.
দেখো, সবাই দেখো, agree করো. D আসছে answer.
জি স্যার।
Okay.
Yes, sir.
আচ্ছা. Do we have Zarif present? Zarif, are you here? Zarif na. What is the name of this kid? Yeah, Mustahsin Zarif. Are you here?
Sir, he isn't.
Koi. Where is Zarif? What is your username? He is not present today. No, he's not. Never mind. I just needed to tell him something. Anyway, we'll move on. This problem, however, is repeated multiple times throughout this entire paper. Number 13, it shows up here at 15. So, the significance of this repetition is that this question was actually repeated in CA paper, CA questions. So in multiple years, this question popped up. So pretty important question and pretty simple to confuse if you haven't come across this question. The most common mistake is that what the students do, they assume that T1 is exclusive for X and T2 is exclusive for H. That is the wrong thing to think. That's not the case, which I highlighted earlier. Anything else from this page? Page number 12, anyone? Page number 13. Page number 13. Anyone?
No, sir.
I think we did discuss about this graph in halfway in our lecture while we are discussing the idea of air resistance, effect of air resistance. We did cover this MCQ exclusively while we did the lecture part, so that pretty much covers it. Let's go for 2.4. Have a look. Question number 1. I'll discuss number 1 anyway. Have a look at question number 1. A student measures the time t for a ball to fall from rest to a vertical distance h. Knowing that the equation h equals to half gt square applies, the student plots the graph shown. Which of the following is an explanation for the intercept on the t-axis? Which of the following is an explanation for the intercept on the t-axis? Now, try and understand. We plotted a graph of root over h versus t, which pretty much makes sense because we know that h is proportional to t square, or root over h can be also proportional to t, which works out. And for an object dropped from rest, as it says, if you drop an object from rest, then the equation is supposed to be what? Equation might as well look like this: h equals to ut plus half at squared. So if you take this part out, if ut is not there because u is 0, so you essentially get h equals to half at squared. So which it gives you that h proportional to t square, or you can also say root over of h is proportional to t, which works out. So essentially, this graph is supposed to be a straight line, which makes sense, and it is supposed to pass through the origin for an appropriate setup of graph. But that is not the case over here. You can see that this graph is having an x-axis intercept, x-axis on the positive side, or in other words, we can say if we extend this line further down, this line is having a negative y-axis intercept. If this line is plotted further, assumed to be plotted further down the line, the possible cross point on the y-axis would happen at a negative y-axis. So that is also somewhat possible. Now let's have the question is asking is that which of the following is an explanation for the intercept on the t-axis? So how could we explain this? Let's have a look at these 4 possible options. A says air resistance has not been taken into account for large values of h. Well, if air resistance was supposed to be taken into account, this graph is supposed to become a curve, because if air resistance was actually a variable, in that case this acceleration is not supposed to be constant. This is supposed to have a different value. So you're not supposed to have a constant gradient. You're gonna have a curved gradient, because either the h value should be different. I'm not saying it will be plus or minus, but simply put, you're not going to have a straight line. So air resistance has not been taken into account for larger values of h. This is actually true, but that does not specify why the error over here is happening, because what this graph represents, that whenever root h is 0 or h is 0 per se, you still have some time happening. If you try to understand the physical meaning of this intercept, it means that time count starts from here. At t equals to 0, the object is at h equals to 0. As time goes by over for this much duration, the object is still at rest and hasn't started its motion yet. The object starts its motion from here, which means you are starting the stopwatch every single reading by this much time earlier than the object started to fall. Or in other words, we can say your stopwatch had a zero error. That let's say you are starting the stopwatch and you're supposed to measure a time duration of, let's say, 10 seconds, but your stopwatch is giving you 12 seconds. So you're measuring this much time extra, let's say that is 2 seconds. So you have a 2 second of zero error in your stopwatch. So every single time measurement was somewhat longer than what they're supposed to be. So this time measurement was this much longer. So this point was supposed to be plotted here. This point was supposed to be plotted here. This point was supposed to be plotted here. If all of these points move by this much horizontal distance to the left, you might as well get a straight line passing through the origin, which did not happen. This means your time measurement was always subjected to a systematic error, or a one type of error which shifted your entire graph in one side. In this case, further on the right side of the x-axis. So have a look at this information. Which one do you think is the correct response?
B.
B.
B is the correct response, but can we ever altogether understand why A, C, and D should not be correct response? Read all of those three options as well and come to a decision that yes, I can successfully eliminate those options with appropriate logic. Everyone, read through. If you have any question, you ask me.
C-তে বুঝান কেন?
C-তে বলছে হচ্ছে there is an error in the timer that consistently makes it run fast. That consistently makes it run fast would mean that you're not subjected to a systematic error in the sense of zero error, but you are you have a systematic error that your total measured time is always somewhat smaller or larger. Your total measured time is always larger than the actual time by a certain proportion. Let me elaborate what I mean. Let's say, try to visualize this idea. Try to think of an analog clock. Let's say in 1 minute of time, the second hand is supposed to rotate 360 degrees. Am I correct?
Yes, sir.
Yes, sir.
That is the way any analog clock works for a 1 minute duration. Let's say in a 1 minute duration, the second hand is supposed to rotate 360 degrees. Now, if the clock runs faster, it means for every minute it will run slightly more faster. So let's assume that a certain clock has developed a certain kind of error that it covers a bit more than 360 degrees in 1 minute, in actual 1 minute of time. Let's say a certain clock operates in such a way that it measures 5 seconds more for every 1 minute, which means that in an actual duration of 1 minute, that clock will read you 1 minute 5 seconds. In the next 1 minute time, that clock will read you 2 minutes 10 seconds. So you will have incremental error increasing. See if it makes sense.
Yes, sir.
Running faster means that this gives you the clock hand rotates faster than it should, which means it will give you a bigger reading of time compared to the actual reading of time supposed to be. Now, this will give you random error in, not random error. This will give you a type of systematic error in your readings. I'm saying systematic error because for this kind of an error, all of your time measurements should be somewhat longer than they're supposed to be. But truth be told, actually, let me take this graph. Let me take this graph in the pad, and let me discuss this over here. It's a good point to cover. It's a good point to cover. So what I mean is that in that case, smaller time durations would have a smaller amount of plus error. Bigger time values would have a bigger amount of plus errors. Get this. The point that I'm trying to make, that in this case, you have a specific fractional error added, fractional error added to all of your time values. Kirokon fractional error? For every 1 minute of original time, the additional time is 5 seconds. See if you can capture this information. For every 1 minute of time, actual time measurement, the additional time we get is 5 seconds. So you see, there is a fractional information. So if your measured time is 10 minutes, then you are supposed to get 50 seconds more. If your measured time is 12 minutes, you're supposed to get 60 seconds more. You will always get more time measured by your stopwatch, but how much more is it gonna be is not a fixed number. It is a variable depending on how much time are you trying to measure. bigger time measurement giving you bigger error, smaller time measurement giving you smaller error. So in one way we can say this, that this device has a systematic percentage error, something that we might have come across in an MCQ which was in 2.1. No, not 2.1, 1.1. Let me take you a reference so it will be easier for you to correlate the acha, what does it actually mean. ডিগ্রি সেলসিয়াসের একটা কোশ্চেন ছিল না, কোথায় জানো? একটা স্ট্রেট লাইন গ্রাফ ছিল এন্ড দেন
চারটা গ্রাফ যে
না দাঁড়াও দেখতেছি পাবো।
I think it's number 30.
Which part?
The last part.
Yes, thank you. I was looking for this one. Yeah, thank you very much. Ifat.
You're welcome, sir.
Have a look. This question read a quantity x varies. So I'm getting back a little bit to get you a reference of this MCQ choice. A quantity x varies with temperature with theta as shown. Theta is determined from the corresponding values of x by using a graph. X is measured. X is measured with a partial uncertainty of plus minus 1%. So have a look. Here x has a value variation of plus minus 1%. What does it mean? The bigger the value of x is, the higher the absolute amount is. But your absolute amount of delta error of x or delta x would be always a fixed fraction of the original number. Try to understand. That's what I mean having a faster clock, which means that if you are trying to, your error will always be such that for every 1 minute of time measurement you'll have a plus 5 seconds. So you have a fixed fraction of increment, but the absolute value of the increment is not same. Do I make sense? So for that kind of an error, let me just take this graph. This is an errorful graph, but let me just show you possible other options so that I can make sense to you. Let's say this is the actual graph. The true graph, let's say, is supposed to look like this. Let's assume that the correct graph is supposed to look like this, because these values were said to have some systematic error. So the actual graph is supposed to be like this. So all the values should be this much pushed to the left to have a smaller time reading. If we have a fractional based systematic error in our measurement device, that is, if the C option was correct, C option ta ki chilo, there is an error in the timer that constantly makes it run faster. In that case, all of those errors would be incrementally big. Incrementally big bolte ki bujhacchi, I'm gonna take out this original graph because I don't want to confuse you kids, so I'm taking this out. Lagle pore amra abar introduce korte hobe, সমস্যা নাই, but I do not want it to be here. So what this will mean that every single value, let's say a value is supposed to be measured here, this value is going to be slightly bigger over here. A value that was supposed to be measured here, this value will have even a bigger gap. Have a look. এখানে gap to হচ্ছে এটা, এখানে gap হচ্ছে বড়. A value that is supposed to be measured over here, that will have an individual gap even bigger. Because the bigger the amount of t that you're trying to measure, the bigger is the amount of error that you're going to make. Which means in this case also you're going to get a line that will be straight line that passes to the origin, only it's going to have a different gradient because you're going to have proportionately bigger value with the t-axis. But your graph would still pass to the origin. If you wonder why, because when the measured value of t is 0, your fractional uncertainty is also 0. 0 second is 0 second in both of your actual correct stopwatch and your wrong stopwatch. But 1 minute is not 1 minute in both cases. 2 minute is not 2 minute in both cases. Do I make sense?
Yes, sir.
এই ডিসকাশনটা কি বুঝা গেছে?
জি স্যার।
আচ্ছা, ডি কেন হবে না সেটা বুঝাবো, সমস্যা নাই। Any question about option choice C? Could I make it clear?
অ্যানসার তাহলে সি না?
না, কারেক্ট आंसर হচ্ছে বি। সি হইলে এরকম হইতো, সেটা আমি বলতেছি, বাট এরকম
আচ্ছা স্যার।
অ্যাকচুয়াল গ্রাফটা তো এরকম না, অ্যাকচুয়াল গ্রাফটা ছিল অন্য, যেটা একটু মুছে ফেললাম।
বুঝছি।
ঠিক আছে? আচ্ছা,
তাহলে মূল কথা হলো এরর গুলা কম্পাউন্ডেড হয়ে একদিকে ডিভিয়েট করতে থাকে।
এবং এই কেসে সবগুলো এররের অ্যামাউন্ট সেম, সবগুলো ভ্যালুকে সে একটা ফিক্সড অ্যামাউন্ট অফ প্লাস এক্স করে ফেলছে।
আচ্ছা, কিন্তু তাও সে অরিজিনের মধ্যে দিয়ে যাবে যদি সি হইতো।
যদি সি হতো সেটা অবশ্যই আমাদের হ্যাঁ অরিজিন দিয়ে যাইতো, বাট আমাদের এররগুলো ইনক্রিমেন্টালি বড় হইতো।
আচ্ছা,
এবং যেহেতু বলছে যে দ্য ক্লক রানস ইট ফাস্টার, making the clock runs faster means all the relevant time measurements are supposed to be longer than what they are supposed to be. If this word said that the clock makes it run slow, তখন আবার গ্রাফটা চলে আসতো উপরের সাইডে। If this word read that the clock runs slow, তখন সবগুলো মেজারমেন্ট টাইমগুলো হয়তো কি পসিবল অ্যাকচুয়াল অ্যামাউন্টের থেকে কম কম আসতো, এখানে কিছু কম আসতো, এখানে আরো কম আসতো, এখানে আরো কম আসতো, এখানে আরো কম আসতো, then this graph is supposed to be on the upper side than the original graph.
আচ্ছা,
বুঝো, running faster and running slower are two different information. Running faster means all the time measurements would be somewhat bigger. Running slower means all the time measurements would be somewhat smaller. So that's the difference. But all of these graphs, when properly drawn, are supposed to pass through the origin. They should not have intercept. বুঝতে পারছি? সিনেমাটা কি ক্লিয়ার হয়েছে সবার? Okay. As for option test D, the student should have plotted h against t squared. আচ্ছা ঠিক আছে, সমস্যা নাই। নাজির, থ্যাংক ইউ। The student should have plotted h against t square. Well, h against t square plot করলেও আমাদের এই এররটা এরকমই থাকতো, because দেখো, I mean the idea is very simple. H against h versus h is proportional to t square. That is also the reason why h proportional to t works. So if you have an error in this graph, you're also going to have the same error in that graph as well. If the student did plot h against t square, that error wouldn't have been missing. That error would still be present. You can still, if this graph does not pass through origin, there is no reason this graph can pass through the origin. So this does not essentially help us to give us a reason what is the problem. I mean, this does not essentially explain the problem. This is just giving us a proposition what the students could have done, but that does not even solve the problem. Neither it is the reason for why the problem was developed in the first place. So this option is just, this is a trap sort of question, because students are more acquainted with this expression, they are less acquainted with this expression. So some students might fall for this, that if they plotted h against t square, everything would be beautiful, but that's not the case at all. বুঝা গেছে? মাহিয়াত, you asked for the option expression for D. Does it make sense? Oh my God. I'm sorry. Mahat, you send me something, but there is no way I can make sense out of it. Acha, it's okay, but did the explanation make sense? Acha, okay. Moving on. So that was question number 1 from this paper, which paper? This paper. Yeah. So we are here. So anything else from this page? 2, 3, 4. বললাম গ্রাফের কোশ্চেন এমসিকিউ গুলো তোমাদের খুব ভালো মতন বোঝা লাগবে. There is a reason I'm taking so much time in these MCQs, because graphs can be stuffs. I mean, graphs are stuffs which can have a lot of inherent information that is hidden in plain sight. So it's very much possible that unless you are pinpointed to those information, you might not as well see that. So it's important that you solve your graph questions and ask problems that you have. Anything else from this page, anyone? Number 4 বুঝা গেছে সবার?
Yes, sir.
5. আচ্ছা,
Sir, 5 টা একটু দেখা দেন।
Which feature of a graph allows acceleration to be determined? Acceleration is the gradient of VT graph. Acceleration is the gradient of velocity time graph, because velocity time graph এর gradient হচ্ছে del v by del t. Del v by del t is by definition acceleration.
Yes.
So D is the only choice. I love question number 6 because question number 6 is a perfect graph for a bouncing ball case. তোমাদেরকে আমি পড়ানোর সময় bouncing ball case পড়াইছিলাম
Ji sir.
Kinematics পড়ানোর
Yes,
সময়
Sir. Ji sir.
I did. I don't remember. That was before Eid,
Yes,
right?
you did. Ji sir.
Acha, that was before, so I don't have fresh memory of it. But this you should be able to make sense of this graph right now really easily. Here was the release. Here is the first fall, first impact. This is the hitting velocity, but this is the rebound velocity. Rebound velocity is less because energy was wasted. And this is the this is the point where the ball leaves from the ground. Once again, this is rise, and this is the highest point of the ball after the first rise, which is less compared to the dropping point because you can see that the fallen height is larger, but the rising height is smaller. But whatever the rising height is over here is the same as the fallen height after the first after the first bounce. So these two areas will always be equal. Then happens the second impact, and bam, 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 it keeps on falling. It's a very nice graph. The labelings are also very good. Makes sense. So page number 16. Any question from page number 16?
Number 6.
This one?
Yes, sir.
Okay, বলো কোথায় সমস্যা কোন পার্টটা বুঝে নাই বলো
So এটার অ্যানসারটা কি?
মানে কারেক্ট আনসারটা কি হবে
হ্যাঁ।
কারেক্ট আনসারটা তুমি আমাদের যে আনসার কি আছে ওখান থেকে দেখো
There's D.
You should have access to the answer key PDF which is
Sir, আমি পাইনি।
এটা এই যে এখানে আছে
Sir, চ্যাটে আছে।
চ্যাটে কোথায় আছে তোমাকে দেখাই দিতেছি if you go from your PC over here collapse all of these unnecessary stuffs here in the shared files. If you go further down and give show all, you'll see somewhere over here there is a PDF that should read answers in tables. Here it is. Do you see it?
Yes, sir.
Yeah, this is the one. So you have all the answers within this part. Okay. Anything else? 11. I think 11 is a problem. Is 11 a problem? On page number 17. Anyone?
Sir, number 12 টা।
Ji sir, 12.
I'll help for 12. Acha, Ridwan, you are making a query that মনে হয় না bouncing ball পড়ানো হয়েছে. I think আমার bouncing ball পড়ানো হয়েছে আছে. যদি পড়ানো না হয়, I'll look into it in after the class, and if it was not covered, I'll definitely cover it in the next class. So don't worry about that. But I believe it was. If it, so I'm gonna go through the playlist and try to find out if it was ever done or not done. If it is done, I find out. I'll try to share you the time instance. ঠিক আছে?
জি স্যার।
এটা কে বললা?
স্যার আমি রিদওয়ান।
তুমি যে কথা বলতেছো তোমার এখানে মাইক্রোফোনের অপশন আসতেছে না কেন আইকন আসতেছে না কেন ও আচ্ছা হ্যাঁ পাইছি সরি my bad never mind so 12 is a problem that which we are going to cover 12 টা খেয়াল করি question number 12 is a pretty confusing problem and 12 টা খুব commonly স্টুডেন্টদের ভুল হয় for only one reason that is we happen to become unable to distinguish between graph and actual collision figure. Let me elaborate what I mean. Have a look. The graph shows the variation with time t for the momentum of a ball as it is kicked in a straight line. Initially, the momentum p is p1 at time t1. At time t2, the momentum is p2. What is the magnitude of the average force acting on the ball between times t1 and t2? Here's the thing that I need to understand. This is a graph. P2 is the symbol for a number. So P1 is the symbol for a number. P2 is also the symbol for a number. The value of P2 is -1, something minus. But is the symbol minus? For example, let's say this is X, this is Y. X is X, Y is Y. Let's say X equals to +10 and let's say Y equals to -10. The value of X and Y can be positive or negative. Or P1 is a positive number, P2 is a negative number. But P2 symbol, the symbol itself does not have a minus sign embedded within itself. So if you're trying to find out the change in momentum, you might as well write P2 minus P1. When you are going to place the values, then P2 should show up as a minus value and P1 should show up as a positive value. This is why the correct response for this question is B. Am I correct? I think
Yes, sir.
Yes, sir.
B is the correct response. Then the reason is that because the question is asking what is the average, what is the magnitude of the average force. So they disregard the part of the value. So P1 and P2 are the symbol for two numbers. Whenever you will place the actual magnitude of those numbers in your equation, naturally P2 will become negative and you will do the mathematical operation of addition. Now the reason this question seems to be confusing because of one thing. Let me show you. I'll elaborate this part. The reason it is confusing is that in this case, this was labeled as a graph. Situation would be completely different if this was shown for an actual collision figure like this. If it was labeled for a certain scenario that let's say this much is P1 and this much is P2. If this was labeled like this, then the answer would always have been P1 minus P2. Because here you can see that if you take this one as a positive quantity, as a vector, you cannot write this as a negative quantity. You cannot write this as a positive quantity. So by default, তখন P2 সামনে একটা minus চলে আসতে হতো. As a result, in that case, the correct answer could have been D. But here, P2 is labeled on the graph. So P2 is a P2, which is a symbol for a number. The magnitude of this number is going to be negative, something negative. So whenever you replace this value over here, you're going to put that P2 value as a negative number. But whenever you're writing this in terms of symbols, this is what it should be. Do I make sense?
Sir,
Bolo.
sir, can you explain the collisions between these balls?
This part. This one?
Yes.
If the collision between these two particles was shown in an actual figure of collision, let's say P1 is the momentum of the left ball, it's a ball 1 coming from left to right, and P2 is the momentum of the ball coming from right to left. And after collision, or not after collision, let's say, I actually drew the this figure wrong, my bad. I erased it because this figure was drawn wrong. I should have drawn it in this fashion. Initially the momentum was P1, and after that the momentum was, let's say, somewhat P2. Now in this case, if the figure was shown like this, in that scenario this would have been P1 minus P2 for magnitude. But if the case was like that initially the ball was going in this direction as P1, and after the kick the ball is going in this direction as P2, then what should be your momentum? What should be your change of momentum? That would have been P1 minus P2. See if it makes sense. Because these two are labeled values of momentum. So if you consider this one as a positive number in your equation, this one definitely should come as what?
I need to consider
Negative
that
number.
thing as a negative.
So over here, this should naturally become P1 plus P2. So what I'm trying to show you is that this is the actual case for which this graph makes sense, not this one. Because you can see that initial momentum was a positive value and the final momentum is a negative value, which means after the kick, the direction of the momentum got changed. So if this entire scenario was shown in an actual figure like this, and the momentums were labeled as values on the object, then this one could have been the correct answer. But that is not. Here P2 is labeled as a certain number on your graph. P1 can have a positive value, let's say I use the example plus 10, whereas P2 will have a negative value just because of the axis of the graph, which can be minus 10. So whenever you replace those values over here, you're going to get what? 10 minus 10. So ultimately your mathematical operation will still be positive. But if you're trying to represent these two values as numbers on the graph paper, not by labeled momentum on the figure, that's the key point. If you're trying to express this momentum change as numbers on the graph axis and not that they were labeled as actual momentum on the object, you cannot consider P2 as a by default negative value. P2 is not a negative number. P1 and P2 are just numbers on the graph axis. The idea of direction is not applicable for numbers on axis. Whenever you're going to replace them in your actual equation for actual values, they will automatically become negative. বুঝা গেছে কি?
Okay, sir. Thank you. Ji, sir. Thank you.
Everyone else, please respond. It's important that
sir.
you understand the difference of this thing and difference of this thing. These two things are not equal. Moving on. Page number 17 থেকে আর কোনো problem? Anyone else? 17 থেকে আর কোনো problem? Page number 18. Page number 18. এটা কি ছিল? আচ্ছা, ট্যানজেন্ট আঁকতে হবে। Never mind. আচ্ছা, আমি এই পেজ নাম্বার 18 এর কোশ্চেন নাম্বার 18 টা একটু আলাপ করি। এই কোশ্চেনটা একটু আলাপ করা দরকার আছে। এটা খুব ডিফিকাল্ট কোশ্চেন না, বাট স্টুডেন্টরা কমনলি এটাতে ট্র্যাপড হয়। Have a look. This is the given information that a certain object has an acceleration time graph that looks like this. Which one of these four options, A, B, F, C, or D, would be the VT graph? What is the most common wrong response? Someone tell me.
D.
No.
C.
Yes. C is the most common wrong response. I'll tell you why. The kids see that acceleration value একবার বাড়তেছে একবার কমতেছে, তার মানে অবজেক্টের ভেলোসিটি একবার বাড়বে একবার কমে যাবে। So they very confidently go for C, which is wrong, because the magnitude of acceleration is increasing and decreasing. True, be my guest. But is the direction changing?
No.
Oh, sir.
The direction is not changing, which means the object will always undergo increment of velocity. Velocity will always be ever increasing. For low values of acceleration, it will be increasing slowly. For higher values of acceleration, it will be increasing faster. But it will never go in the opposite direction. Not gonna happen. Because acceleration is working in the forward direction, in one direction only. So your velocity has to be rising ever, which is covered in A or in D. So B or C bad. And then again, if you compare the shape, this one represents a low gradient at the beginning, and then the gradient of the VT graph should increase. Gradient of VT graph should peak at this level, which is somewhere over here. Highest gradient represents the maximum acceleration. And then as further time goes by, the acceleration is decreasing. So the gradient of this graph is also decreasing. So change of acceleration should be interpreted back into the velocity graph. Or in other words, you can try to obtain the, you can try to see that whether the gradient that we see in all four of these options perfectly matches over here or not. All of these acceleration values over here are positive, which means these VT graphs should all have positive gradient. Only available in A or D. And the rest of the part is very simple.
স্যার সি কখন হইতো?
Hold up. মামুন, এটা একটু খেয়াল রাখো তো, এটা ঝামেলা করতেছে। তোমার কিছু করা লাগবে না, তুমি একটু খেয়াল রাখো, তার গলা কিছু আটকাছে মনে হয়। হ্যাঁ, এখন সে লাফালাফি করতেছে, সে মনে হয় বিপদে আছে। তুই ছাড়া দাও সে একা একা ট্রাই করুক সে পারবে পারতেছে না নেভার মাইন্ড করুক কিছুক্ষণ স্ট্রাগল করুক অভ্যাস হবে so C could be an answer if you want to go for the find out the acceleration time graph of C it is very simple have a look this is a sine curve right
Yes.
by shape this is a sine curve what is the differentiation curve for a sine curve
Cos curve.
so basic idea so acceleration এই গ্রাফে acceleration টাইম গ্রাফে শেপ হবে হচ্ছে acceleration টাইম গ্রাফে শেপ হবে হচ্ছে এরকম কি বুঝলা বুঝলা
Yes, sir.
জি স্যার
সিমিলারলি এই গ্রাফ থেকে যদি আমি ডিসপ্লেসমেন্ট টাইম গ্রাফ বের করতে হয় সেই গ্রাফের শেপ কেমন হবে you have done this differentiation you have also done integration so you tell me about this এই ভিটি গ্রাফের যদি ডিসপ্লেসমেন্ট ভার্সেস টাইম গ্রাফ আঁকতে চাই সেটা শেপ কেমন হবে
মাইনাস কস কার্ভ
বিউটিফুল কারণ সাইন রেশিওকে ইন্টিগ্রেট করলে মাইনাস কস হয় মেক সেন্স
Yes, sir.
আচ্ছা মুভিং অন question number 21 is the problem I believe or is it not a problem
Sir, দেখায় দেন।
take a look a small glider moves along a friction-free horizontal track as shown in below at each end of the air track there is a perfectly elastic buffer which graph represents the variation with time t of the velocity v of the glider as it moves between the two buffers. First of all, it says it's an friction-free air track, which means as the glider will travel from one buffer to the next buffer, it will not lose any velocity. So from one buffer to next buffer, it will be uniform velocity or the magnitude should be constant. After colliding with the buffer, there should be a direction change. Also, it says both of these buffers are what? Perfectly elastic buffer, which means after the collision, they will not also undergo any type of what? Reduction of velocity. You will not have any reduction of velocity. So you'll only have velocity direction change, which makes the only character as D. What it shows is, let's say the glider starts from here, goes from one glider to another glider straight line and gets the velocity change, but these two magnitudes remain exactly equal. It then bumps backwards, so it's now having leftward velocity, hence negative, travels for the same amount of duration. Same amount of duration is important because you have to understand the gap between this from one glider to glider is same from left to right or right to left, which brings us to the idea the area of this triangle and the area of this rectangle and the area of this rectangle, both of these rectangles should have the same area because this area represents what? Left to right distance. This area represents right to left distance. These two distances are not supposed to be unequal. They're supposed to be very much equal, right? বুঝতেছো কিনা দেখো so D is the correct option over here. Okay, anyway, I'll cover the other options. For one specific change of this description of the question, for one specific change or multiple specific change, whatever change of this question, B could have been a correct answer. Can anybody tell me what change should there be if B is to be the correct answer? What change should have happened in this description for B to be the correct answer?
Inelastic buffer.
Inelastic buffer, true, correct. Everyone else, think about it. If you have inelastic buffer, then you can have B, not A. এর জন্য ইনএলাস্টিক বাফার হইলেও আরেকটা ঝামেলা ছিল, এটাতে একটু পরে আসতেছে, ইজ এ বিট ডিফিকাল্ট টু describe. আগে বি নাম্বারটা বুঝো. The idea of B is that if this option read inelastic buffer, that would mean in every single collision with the buffer, some velocity would be lost. But if the object for the consequent motion, for the further motion, right after motion, if the glider moves with a lower velocity, then it should definitely take longer time to cover the distance. That is exactly what is shown over here. Have a look. Here, high speed coverage to cover this much area. The speed got lowered. Have a look. This is the hitting speed, but this one is the rebound speed. Rebound speed is less. Do you see that? Compare the two magnitudes. A speed এসে hit করছে, a speed rebound করছে. The rebound speed is less, proving that the collision was inelastic. But the distance between the two gliders should not change, which means in this case, the time required to cover the distance should be more, so that these two areas should be exactly equal. Once again, these two areas should be exactly equal, but the speed has become even smaller, so the time has got even longer. Similarly, over here, similarly further down the line. Does this option make sense? Kids,
Yes.
respond.
Yes, sir.
Now you tell, bolo.
Velocity or why is velocity constant for a longer time each
Because-
time it hits the buffer?
Because friction free. As it travels from one glider to the next glider, there is no friction.
Velocity decreases, so ওইটুক distance কম fit করতে হয়। কত
Yeah.
বেশি time লাগে।
Velocity decrease only happens for the duration or for the instance of the collision. But in between the collisions, the velocity remains constant because the track is friction free. I'm going to cover more options over here. This discussion is going to go a bit longer. How could you possibly change the quotient for A to be a correct answer? Who said sir?
স্যার আমি
বলো।
স্যার ইলাস্টিক বাফারটা কি করে?
It makes a perfectly elastic collision so that the glider rebounds with the same exact speed as it was coming with.
স্যার
যতটুকু
এর ডাইরেকশন তো এক
Answer energy lose হয় না, এটাই তো।
এনার্জি লুজ হয় না, এক্স্যাক্টলি যতটুকু কাইনেটিক এনার্জি হিট করবে ততটুকু কাইনেটিক এনার্জি সে রিবাউন্ড করতে পারবে।
The velocity তো same থাকে।
না, ভেলোসিটি সেম থাকবে না, স্পিড সেম থাকবে, ভেলোসিটি উল্টা যাবে।
Oh, sorry.
ভেলোসিটি ইজ এ ভেক্টর, সো ইউ
Speed
ক্যানট সে
বেশি থাকবে। Velocity উল্টে যাবে কিন্তু magnitude same থাকবে।
এক্স্যাক্টলি দ্যাটস হোয়াট আই মেন্ট। সাদিয়া বলো।
স্যার যে বাউন্স যে করবে এয়ার তো একদিকেই মানে এয়ার তো একদিকে ট্রাভেল করতে থাকবে, পিছের দিকে কিভাবে এই গ্লাইডারটা যাবে?
আচ্ছা আচ্ছা,
এগেইনস্ট হয়ে যাবে না?
this glider is moving back and forth because someone already gave it a little bit of push and the motion is continued further. This glider is not being moved by air. Air is only providing a small cushion between this triangular support and between the glider. Actually, এই glider এখানে ছোট ছোট tiny অনেকগুলা ছোট ছোট হোল আছে. These holes are pushing out air at a very low speed, which makes a very small film of air between this glider and the surface of this triangular track. So
That
practically
is to
speaking,
make it friction free, right?
exactly, practically this glider is floating on air, on a very thin film of air, that is. বুঝছো?
Sir, তাহলে এখানে air resistance আমরা negligible ধরে নিচ্ছি।
Obviously, because the quotient is friction free, air resistance is, all sorts of resistance are zero. সাদিয়া বুঝছো পারটা?
ইয়েস স্যার।
Acha. Now, my question further. How could you change the description of the question if A has to be a correct answer?
Friction দিয়ে দিব। না, friction দিলে তো velocity কমবে।
Sir, inelastic buffers and the buffers are move closer together as time.
Absolutely correct. Think about what your classmate just said. Acha, everyone else, try to take a bit more time to think about this. Before I give you the answer, try to think, to get a little bit of idea. How could you possibly change the description to make this one the correct answer?
Inelastic buffer মানে speed কমতে থাকবে। But sir, next partটা বুঝি নাই। Buffer কেন কাছে আসতেছে না?
Have a look. The duration between the collisions for these graphs are made exactly same, right?
Yes.
So do you think that these areas would be exactly equal?
No,
What is happening to these areas?
they're decreasing.
Which means what? between every single collision, the glider is covering less distance. How is it possible to achieve? Is this possible to achieve if these buffers were slowly brought in closer? Glider is taking equal amount of time to bounce back and forth. We are making sure of that. Just to enable that to happen, so that the time duration between every collision is equal, we have to bring the buffers closer. Exactly. If you bring the buffers closer, physically, if you bring them closer by some mechanism, whatever, then you can achieve this kind of a graph. See if it makes sense. আচ্ছা, যারা যে কোশ্চেনটা করছো ইলাস্টিক বাফার গুলো কিভাবে স্ট্রেচ হবে গ্লাইডারটা টি না কমলে, ওয়েল these elastic buffers could be made from some sort of elastic material which hypothetically is capable to undergo some deformation and reformation without converting any part of the elastic energy into heat. So তারা যতটুকু এক্সটেনশন হয় তারা যতটুকু পি স্টোর করবে নিজেদের মধ্যে, ইলাস্টিক পটেনশিয়াল এনার্জি স্টোর করবে, when they will expand, they will be able to transfer that equal amount of P back into the glider. That's the assumed scenario. Practically, it achieve kora possible na. Any single time any object undergoes some deformation and reformation, it will always convert some heat energy. Zara buchho?
জি স্যার।
Acha. So let me cover up some other questions. Option C is an absolute bakwas. এটা কোনোভাবেই হওয়া পসিবল বলে, মানে এটা ডেসক্রিপশন অ্যাকচুয়ালি ডেভেলপ করা খুব ডিফিকাল্ট, সো আই এম নট ইন্টারেস্টেড ইন গোয়িং ফর দ্য আইডিয়া অফ দিস ওয়ান। বাট
স্যার এটা করার জন্য আরেকটা এক্সটার্নাল ফোর্স দিতে হবে না গ্লাইডারের উপর?
না, এটা আরেকটা ফোর্স দেওয়া লাগবে না অ্যাকচুয়ালি আচ্ছা, ইটস নট ভেরি ডিফিকাল্ট টু এক্সপ্লেইন দিস প্রবলেম। আমি বলি, দেখো এখানে দেখো একটা আপ টু সার্টেন ডিউরেশন অন দ্য হরিজন্টাল এক্সিস দ্য টাইম ইজ equal. I'd say that up to this much time each of the segment has the same amount of time. Have a look, this much, this much, this much, this much, এখান থেকে কমে যাওয়া শুরু করছে। From here the time between collision is reducing. Can you make this observation, everyone? Have a look.
Yes.
From this one, this one, this one, this one, up to this much point the time between every collision was same. From here the duration between the time between the collisions were decreasing, and as you can see also that all the collisions are returning the same amount of speed, which means the buffers are elastic. And to describe this change, I can say that the buffers were elastic and the buffers were held at fixed position up to the fourth bounce, 1, 2, 3, fourth bounce. After the fourth bounce, the buffers were slowly brought in closer, because you can see that the distance covered are slowly becoming less. You can see that amount of gap over here, area over here, is bigger compared to the area over here. Am I correct?
Yes.
And then there is even lower over here, even lower over here. So I can say that up to the fourth bounce, the buffers were held in fixed position. Beyond that point, the buffers were slowly brought in closer. See if this description fits in your brain. See if you can accept this description. Everyone, agree to this. Or if you have question, you ask me. If you don't, then I'm gonna start doing another change. And that change is that if we say that this thing was not friction free, if we make this statement rough, and let's say we start with the perfectly elastic buffer. For a rough track and perfectly elastic buffer, how would the graph look like?
স্যার স্ট্রেট লাইন না হয়ে ওগুলো একটু মানে একটু স্লোপ হইতো তখন।
কোন দিকে?
ইয়ে
ডাউনওয়ার্ড
মানে স্লোপিং হতো।
মানে কি ডাউনওয়ার্ডস হতো?
না না, মানে গ্রেডিয়েন্ট
এক্স্যাক্টলি রেক্ট্যাঙ্গুলার থাকতো, শেপটা মানে ট্রাপিজিয়ামের মতো হয়ে যেত।
Okay, trapezoid মতো হতো। So কোন পার্টটা চেঞ্জ হতো? So are you saying something like this?
No sir.
No, sir. The horizontal.
So something like this.
No
No,
sir.
sir. But
The top part of the
downward
rectangle
sloping
would be downwards.
Something like this.
sir,
Yes sir.
yeah.
Achha, and then like this.
No.
yes
Sir.
yes sir.
No.
No. That one will be upwards.
So you could say that these horizontal segments of this graph should be slanted towards the x-axis. That might be a good description. So this part should be slanting downwards, this part should be slanting upwards, should be slanting downwards, like that. It I mean so.
Yes.
You have to understand, if this track is supposed to be rough, then as the glider moves from left to right or right to left, for the in-between movement, you have some velocity lost. And then since I'm starting with the description of perfectly elastic buffer দিয়ে যদি শুরু করি, তাহলে সেক্ষেত্রে গ্রাফটা দেখতে এরকম হতে পারে. Let's say we start from here and it loses some velocity as it travels, and because it is perfectly elastic, so let's say this is where the collision happens. So let's say this much is the amount of speed by which the first collision happens. For elastic buffer, the rebound will also happen at the same exact speed. So a length আর a length দুটো কি হবে?
Same.
This length is supposed to be equal because it's a perfectly elastic buffer that I say. But then again, as the collision finishes and the motion continues further, that speed should even become smaller. But now, since this one has a higher average speed compared to this part, this time should be longer. I dare not to draw any further. So you have to understand the area of this much, area of this much, area of this much, all of these three areas should be equal, because I'm not trying to give you the problem of having the elastic buffers move towards each other or further away. As long as we consider the distances are equal, so the area of this trapezium, area of this trapezium, area of this trapezium, they all should be equal. So because if it is an elastic buffer, perfectly elastic buffer, then the heating speed and the rebound speed should be basically equal. But as the glider travels from one buffer to the other buffer, their speed should be slowly becoming less. Speed becoming less means the speed should slowly approach towards zero. So এটা downward fall করছে, এটা downward fall হবে না, এটা যদি downward fall করে তার মানে কিন্তু স্পিড বেড়ে যাওয়া. This is the velocity time graph. So this is not a speed time graph. Does that make sense?
Yes.
Everyone else, any further question? I'm not going to cover any more variation because that would be very difficult to draw and not essentially required for your syllabus volume. But if you have any question, please ask. Yes, Nazif. Someone else said sir.
Sir, the top of the bar গুলা কার্ভ হইতে পারতো না স্ট্রেট লাইনের জায়গায়?
এই পয়েন্ট গুলা
না, যেটা না মাত্র দেখেছেন ফ্রিকশন সহ।
এটা well, since these graphs are not plotted with values, if we assume that the speed of this glider at the beginning is extremely high, so that air resistance is not negligible, then it could have been a curve. But that curve should also be showing reduction of speed. It could have been a curve if air resistance is a factor. But if you consider a fixed value of dynamic friction, then it can be a straight line. But it could be a curve as well if you consider air resistance is a part of that friction.
So does friction increases as speed increases?
For air resistance, it does. For dynamic friction between surface to surface, no. মানে আমি তোমাকে যদি আরো ভালো মতো গুছাই বলি, for example, let's say you have a piece of brick that is placed on a table and you are pushing it. So there is a friction that lies between the brick and the table surface. How much is that friction? That is something that we call dynamic friction, which develops from the contact of two surfaces. That will always have a fixed value, irrespective of the speed of the brick. But the air resistance that the brick will experience as it travels through the atmosphere, that is highly dependent on its speed. Get the point? The contact friction is usually a constant value between two surfaces, whereas the air resistance or the fluid friction is largely dependent on the speed of the object. Do I make sense?
বুঝছি স্যার।
বুঝেছে?
Yes.
Kids, any further question from here? I guess not. If any other question pops in your head, write that down, draw a possible figure for your question, and send me in the messenger inbox. I'll try to entertain your question. No big deal. So we'll move on to the next question. Anything else from this page?
Sir, number 25.
The graph shows the velocity time plots for two vehicles x and y. The acceleration and distances traveled by the two vehicles can be estimated from these plots. Which statement is correct? Okay. X is the steeper line, y is the more slanted line, but I can say that both of them have the same area because I can see similar triangles, actually congruent triangles. Congruent na? Identical triangles se congruent bole na?
Yes, sir.
Yes, sir.
Because I can see congruent triangles, I can say that the area should be exactly same, that the area between the x line and between the y line. And I can also say just by looking at the, I didn't yet look at the MCQ choices, so I'm just still going through the properties of the graph. From the graph, I can also say that x starts from rest, whereas y doesn't start from rest. Y had an initial velocity when time completely gets started. That's pretty much it, I believe. So have a look at the option choice. Acceleration of x and acceleration of y are the same at 2.5 seconds. That is absolutely wrong. Velocity of these two objects are the same at 2.5 seconds. Acceleration of the two objects were different throughout the motion because they both have straight lines, so they have a constant value of acceleration which was different throughout the motion. The initial acceleration of y is greater than that of x. Wrong, because the gradient of x is bigger. The distance traveled by x is greater than that traveled by y in 5 second period. No, that is not wrong. That is also wrong because both of the distances are exactly equal. Do you guys understand why both the distances are equal?
Yes, sir.
Velocity, area under the graph is equal.
Area under the graph is equal. I mean, if you want to do, you can essentially go for calculation of the areas, which is not needed for your purpose, because let me show you. Let's say this is the triangle that you have, and this is the trapezium that you have. Okay, what does that mean? It says my internet connection is unstable. I just had a notification. First time ever. Do you guys hear me?
Yes,
Yes,
sir.
sir.
একটু আগে একটু
Yes,
ঝাপসা
sir.
এটা কি করছিল? এরকম করতেছিল?
ছিল। There was no voice.
Okay. হ্যাঁ, এই যে যারা যারা এরকম যে এখন যেরকম সাউন্ড করতেছিল একটু আগে আমি মনে হয় এরকম সাউন্ড করতেছিলাম, লাইক দিস।
Yes, sir. You were. Sir, now don't choke yourself.
That sounds like you choking on your cat.
Yeah, just don't do that thing to yourself.
I don't plan to choke on my cat, but I might choke on other stuff. Never mind. Let's not get there. So the distances traveled by x and y in the period of 5 period second are the same. This is the correct response by all means. বুঝে গেছে? আচ্ছা, আমি area equal নিয়ে যেটা বলতেছিলাম, if you have a look at the triangle shape over here, on the left half, the trapezium has this much area more. I mean, left half means I mean this much part for, let's say, for this much part. For this much part, the trapezium has this much triangle more compared to the triangle, whereas on the right side, for let's say this much part, the rectangle, the trapezium has this much triangle less compared to the triangle area. And you can see that these two areas are absolutely equal to each other. I mean, these two areas. Which two areas? These two areas are absolutely equal to each other. So whatever the triangle is missing over here is making up over here. So the areas are essentially equal. I can see it by just looking at the figure because I know this figure. It can make sense to me, but if it doesn't make sense to me, don't go for estimation, directly calculate it out. Use the area of trapezium, use the area of triangle and measure for your own self and see whether these two numbers become equal or not, then answer your question. Which is the safest way, might cost you some time, but it is a worth invested time as long as you make sure that you get the mark.
Sir, clear.
Okay. Page number 20, anything from page number 20, anyone? 20.
None, sir.
20, দেখো, anyone else? 21. 29 question number 32 নিয়ে বলা বানানোর সময় সাফার করবেন 32 একটু আলাপ করি this is a worthy question have a look at the question number 32 read a car driver sharply presses down the accelerator when the traffic lights go green the resultant horizontal force acting on the car varies with time as shown which graph shows the variation with time t of the speed of the car so time count starts when there was still red signal so the car is still waiting on the red signal without any problem
স্যার আপনি কি শেপ শিফট করতে পারেন?
shape shift
Oh, sir, did you just turn into a cat?
no
Back in the human.
one of my kittens just jumped on my lap I think all human beings I mean all animals are sort of shape shifter I mean if you come to think of it do us human being has a fixed shape I don't think so you are in one shape when you are lying down when you are sleeping when you are having a shower you have your hands movement I mean we don't have a fixed shape I mean so technically speaking we are all shape shifters aren't we
Yes.
anyway that
Never
was a
thought of that, sir.
yeah, okay I mean, when I was in my physics class, when I was in my SSC level, I mean, there was this one time that I bugged my physics teacher like anything. Like you cannot even imagine. Maybe the reason that I could learn that much from him, and he was patient with me and other people of my gang who had the same characteristics like me. So there are multiple of us in his class who would ask him physics questions continuously. So one of the time I asked him that the way we define solid, liquid, and gas, I mean, up to our SSC level or up to your O levels, is that solids have a fixed shape and size and volume. Liquids have fixed volume but no fixed shape, and gases doesn't have any fixed shape or volume, anything. That's pretty much the basic definition that you have come across. Am I correct?
Yes, sir.
That's pretty much basic. So what I asked my physics teacher is that, well, we human beings, come to think of it, I mean, we are continuously breathing air in and out, so we don't have a fixed volume, and we can also change our shape because we can make our hand move, and so our shape is also not different. So we human beings, come to think of it, are not we don't have a fixed volume, neither do we have a fixed shape. So are we gaseous material? Because logic would say so.
Or specifically the
And
definition.
then what did he say?
What my physics teacher said, that he was actually quite tired at that time, because I asked this question at the end of a lot of questions that he was willing to pass by. He would answer all of our questions when we asked them after the class, but when we bugged him a lot in class, he was really bothered, and there were a lot of other kids who also get bothered, but we didn't care shit, like and everything. So yeah, what my teacher said, that human beings are not essentially a single state of matter. We are made up of solid, liquid, and gas, all three of them. We don't have a so we are a composite substance. So we cannot be exclusively defined as a single state of matter. Trying to do that would be wrong in the first place.
So every animal is like that.
Exactly. So he gave me that explanation, then I was like, oh.
Yeah, because our metabolism keeps our shapes changing inside as well.
Yeah, we are always, I mean, breathing changes our shape changes. All animals breathe. So you are having your lungs going up and down. You are inhaling air and exhaling air. So we are always at a constant state of shape change.
Yes, so we are shapeshifters.
The division.
Sir.
Yes. Bala.
Sir, do you want me to ask you silly questions and then be like, oh, do you want me to be like that to you?
No. I don't want you to be like me like that, because I can never be as awesome and cool and super genius as my physics teacher was. I can never even think of reaching that level.
So you can try.
So I know deep inside that I don't even deserve that.
স্যার দেখেন ইনশাআল্লাহ কিছুদিন পরে আমরাও আপনাকে নিয়ে ওইটা বলবো।
আপনি তো ওয়েবসাইটে আপনার নাম কুল ফিজিক্স টিচার দিয়ে রাখছেন।
Because I could. I mean, who doesn't want a little vanity? This just happened. I mean, Sir was making up the website and he was saying that, well, I'm making the form for you. What do you want your URL to be? I can choose my URL. He said, yes, you can. Okay, put this down. Then Sir said, this is a bit long. URLs should be short. Shorter URLs are easier for the kids to remember. আমি বললাম না শর্ট লাগবে না, ওরা তো এই URL কোনদিন টাইপ করবে না, আমি ওদের মেসেজ দিয়ে দিব, ওরা জাস্ট ক্লিক করে ঢুকবে। So I was like, okay, fine. Then that happened. Okay, never mind. Let's get back to into this question. The question reads once again: a car driver sharply presses down the accelerator when the traffic lights go green. The resultant horizontal force acting on the car varies with time as shown. So have a look at the graph of the force change. For the first couple of for a small duration at the beginning, the force is 0. So basically the car is waiting in the red light and the accelerators are not pressed. And then when the light goes green, the accelerators are pressed full hard down. So you suddenly have a really big rise of force, and that force value is remaining constant for the duration afterwards. So you have a sudden increase in force. The question is which of this graph would represent the proper variation of the speed with respect to time? So which one do you think should be the correct answer? And you can have an answer, but you also need to answer yourself why the other options are wrong. So that's what is important.
Sir, is A the correct answer?
A is the correct answer, yes. Now think about why the other 3 are wrong.
So C and D is basically ridiculous, but why not B?
Sir, in B it says increasing acceleration, but force যদি constant থাকে তাহলে acceleration constant থাকার কথা না?
Exactly. Have a look. This figure shows you that the force has suddenly rose. The force has suddenly risen. The force got increased to a higher value suddenly, and it remained over there. So try to appreciate this information. Force equals to what? F equals to ma. Whenever you have a fixed value of F, because the mass is also a constant for the car, nowhere in the question says does the question say the mass is a variable. So acceleration should also be a constant. So acceleration being constant means from the instance that the force became available, from this point onwards, we should represent a constant acceleration in our graph. Now for a VT graph, constant acceleration is represented by straight positive gradient line, which is available over here. This is not correct because this is showing you what? That the car was initially at rest and then the acceleration slowly started to increase, and there is no corner on this curve. No corner on the curve means the acceleration was introduced slowly. But as you can see over here, do you think the acceleration was introduced slowly?
No, it was introduced suddenly.
The acceleration was introduced suddenly. Like the driver pressed the accelerators full down at the instance of the light going green. So you are expected to have a sudden shift of gradient over here. What do I mean by sudden shift? Have a look. Try to have a look. For this part of the graph, the gradient is 0. Then at this point, suddenly the gradient changes from 0 to a higher value. So the change of gradient is happening how? Is it happening gradually or is it happening suddenly?
Gradually.
No.
Suddenly.
এখান থেকে এই পর্যন্ত হচ্ছে 0, এখান থেকে এখানে হঠাৎ করে একটা ভ্যালু চলে আসছে. So that pretty much suffices this graph that the change of acceleration is sudden. But whenever your graph is smoothed out like this, you are essentially having your gradient increasing slowly. This should not be the case for the force. I mean, this could have been the case, this could have been an answer if this force graph looked like this. If this force graph looked like this, let's say here is your force versus time. Initially the force was 0, well and good. And then let's say it can start up like that. Then you could have like that. That force is slowly increasing from a 0 value. So the acceleration is also starting to increase from a 0 value. So you have a smooth speed time graph. But that is not the case over here. The acceleration was introduced suddenly. So you need to have a sudden change in speed. That's why you need a corner in your graph, or something that we use in the physics term for the graph property, a kink in your graph. Kink means a sharp edge or determinable edge in your graph. For example, this one is also a kink. This one is not. for this graph, these are the two kinks that you have, where you have a sudden change of value, not a gradual change. Do I make sense? Any questions so
Yes,
far?
sir, you do. কিন্তু স্যার আমি একটা question
বলো question বলো, I'll take. হ্যাঁ যারা question বলো। হ্যালো যা তোমার ভয়েস
আপনি বললেন না কেন কনস্ট্যান্ট হবে ওটা আরেকবার বলছি স্যার আমি বলছি যে এক্সেলারেশন আপনি বললেন না x is equal to equation
okay, so you're asking that you
Sir,
are
can
asking
you
the
hear
question.
me?
Yeah, I think I heard you. Let me
Acha, I'm
repeat
typing. Wait.
No, I'm বলতেছি শুনো, you're asking why this should be a constant. That part was not clear to you, right?
Okay. Yes, sir.
That was the question. Well, we suddenly applied a fixed value of force. Have a look over the duration of this time, that force value is remaining constant, right? So you are exerting a fixed amount of force on the entire car. So the car which has a fixed mass is subject to a fixed force. So F divided by m gives you a fixed value of acceleration. Now, if you think very minutely, come to think about it very minutely, the acceleration was, the mass of the car actually will never be constant, because if the car is supposed to go forward, it is supposed to burn fuel, and that fuel would be converted into gas, and those exhaust gases are supposed to go out. So in minute sense, there would be some reduction of mass. That is true, but we can hypothetically consider that reduction of mass negligible. Do you get my point? I mean, the reason I bring about this idea of exhaust gas, because this factor plays a huge role in rocketry. Because one thing you need to understand, that when the rocket starts its journey from the ground, it is entirely filled up with fuel gas. So it's fuel gas. So as it slowly goes upward, it keeps on burning the fuel gas and make them exhaust go down in the out of its bottom. So it slowly rises up. But as it slowly gives out more and more gas, necessarily the rocket becomes less massive. The mass কমে যাচ্ছে. At the same time, it is slowly going up. At the same time, it is slowly going up in a much less dense layer of atmosphere. So atmospheric air resistance আস্তে আস্তে কি হচ্ছে? কমে যাচ্ছে, right?
কমে যাচ্ছে না।
Not essentially. Air resistance আস্তে আস্তে বাড়বে, because the rocket actually speeds up. So there comes a point where the air resistance and produces the maximum maximum aerodynamic stress. Beyond that point, the air resistance actually goes down. আচ্ছা আমি ওই ঝামেলাতে যাচ্ছি না. The point I'm trying to make, forget about the air resistance part. If you only consider the fact that the rocket propulsion engine produces a fixed amount of thrust or force upwards, and its mass is continuously becoming less, which essentially mean the further for the longer the rocket actually burns its fuels, the lighter it becomes. So same amount of burning capability can accelerate, give you a bigger acceleration. Think about this. বুঝছো কি বলতেছি? So how much fuel?
Can you repeat the last line again?
Yes, the same amount, because if your rocket engine is producing a fixed amount of thrust or force out of using its exhaust system, then you can use the same amount of force for a smaller amount of mass as time goes by. So that smaller amount of force, that smaller amount of mass would essentially allow you to produce a bigger value of acceleration on the rocket. So which is pretty important for the case of rocketry, but for a car case, I don't think that's really important, because for the entire mass of a car, the entire mass of fuel is actually quite small, like seriously small. So that's why we can consider the acceleration to be constant. That's why this speed time graph can have a straight line gradient.
Okay, sir.
Okay, we'll take a small break. তোমাদের ক্লাস কয়টা পর্যন্ত?
7:15.
আচ্ছা আমি তোমাদের একটা জিনিস জিজ্ঞেস করি, আই এম নট ব্যাজারিং এনিথিং ওভার ইউ। তোমাদের এই ক্লাসটা ইউজুয়ালি শেষ হয় কয়টায়? আমার এই ক্লাস ইমিডিয়েট আগের ক্লাসটা শেষ হয় কয়টায়?
মানে স্যার বুঝিনি।
মানে হচ্ছে তোমার আমার
ওয়েডনেসডে ক্লাস বলছেন আপনি?
হ্যাঁ ওয়েডনেসডে
স্যার
আমার
আমার 5টায় বকনা শেষ।
5টায় শেষ হয়।
স্যার
তো ওয়েডনেসডে ক্ল্যাশ করে আপনার সাথে একটুখানি, মানে 45 মিনিটসের মতো।
জারিফের তাই না?
স্যার আমার
শ্রমিক আচ্ছা জারিফ দুজনেই। তোমাদের কি ক্লাস থাকে?
স্যার আমার ম্যাথ থাকে আর কি, 6টায় শেষ হয়।
জারিফেরও তাই?
না স্যার আমার আর রাফিদের।
রাফিদ জারিফও বলছিল তোমার কি যেন একটা ক্লাস হয়, জারিফ কোন না বলছিল? হ্যালো আচ্ছা জারিফ জানি কোথায় চলে গেছে। Never mind. We'll move on. Any further question from this question? Yes, Farhan, you can take a break. No big deal. Anything else?
No, sir.
No. Moving down further. Okay. What? Okay. Try and solve number 36, everyone. Give this a try. Now. Answer match হলে বলো, ম্যাচ না হলেও বলো, I'll help.
স্যার একটু ওয়েট করেন।
হ্যাঁ সমস্যা নেই, I'll give you time.
The match করছি।
আচ্ছা
Sir, answer is 65.
না মনে হয়।
Oh, it's 25.
Yes.
B.
Displacement.
45.
Displacement.
There are so many different ways to make an error in this question. First error is that some people can try to calculate the area of this triangle, which is wrong. Some people can try to calculate the area of this trapezium, which means this triangle plus this rectangle, which is also wrong. Some people can try to calculate the correct thing, which is something else, which I didn't show yet. These are the two most common mistakes. এবং এই আনসারগুলো এখানে আছে অলরেডি।
Answer is 45.
I'm not sure. The hell I do.
25 answer.
25 answer?
Yes, sir.
আমার খালি ঘুম পায়।
ঘুম পায়। আপনার লিখতে হবে না পুরোটা কষ্ট করে।
But I like to add this. আচ্ছা বলি যারা পারো নাই, have a look. This question is about displacement and this was said to be a velocity time graph, which means vector is to be considered. Have a look. The object was thrown upwards with an upward velocity of 30 meters per second. It was rising up and up and up and up. After 3 seconds, it reaches its maximum velocity because this is the point, this is its maximum height, because this is the point where the velocity becomes 0. So উপরে উঠতেছে 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 3 সেকেন্ড পরে সেখানে স্টপ হয়ে
টার্নিং পয়েন্ট হয়ে যায়।
turning point. Beautiful. Beyond this point, it's going to start falling downwards, and we are asked to calculate the height after 5 seconds. So rise এর জন্য হচ্ছে 3 সেকেন্ড, fall এর জন্য হচ্ছে 2 সেকেন্ড। কোশ্চেন হচ্ছে এটুক কত। সো কি করতে হবে, আগে এই ট্রায়াঙ্গেল এরিয়া বের করো। হাউ মাচ ওয়াজ দ্য ম্যাক্সিমাম হাইট রাইজিং?
35.
এরপরে এই ট্রায়াঙ্গেল এরিয়া বের করো। হাউ মাচ ডিড ইট ফেল থ্রু? তারপরে এই দুটোকে সাবট্রাক্ট করো, করে দেখো কত হয়। হেল্প ইয়োরসেলফ এভরিওয়ান।
25, sir.
25 হওয়ার কথা। সবাই একটু করো, I'll give some time to solve it out. That's a nice chicken. Never mind. We'll move on. তারপর প্রবলেম বলো। 43 or anything else?
Yes, sir. 43.
43 is a good one. কোশ্চেন পড়ো সবাই, 43 কোশ্চেনটা পড়ো, আমি বুঝাচ্ছি একটু পর। Try to visualize the setup situation in your head. Try to visualize the setup in your head.
Sir, elastic or perfectly elastic এর difference টা কি?
নাই। So the question says that a student throws a ball in the positive direction vertically upwards, which means downwards everything is negative. As a vector, downwards everything is negative. So if you throw it upwards, acceleration, vertical gravitational acceleration will work downwards. So for the most duration of the of its motion, the acceleration is supposed to be downwards. So A and B are out of the question. That's the first thing you need to decide. Now you need to only work between C and D. So A and B are out of the question because they have messed up the position of the graph, showing it as a positive acceleration while the acceleration of gravity working downwards. So A and B are discarded. It then further reads, the ball makes an elastic collision with the ceiling. With the ceiling, rebounds and accelerates back to the student's hand in a time of 1.2 seconds. Now, think about it. As long as the ball was rising upwards, it was experiencing an acceleration downwards. In the collision with the roof, what will be the direction of acceleration as the ball hits the roof? Or let me rephrase that question for you. In the collision with the roof, the ball exerts a force on the roof upwards. By Newton's third law, the roof also exerts an equal and opposite force, that is downwards, onto the ball. So the question is, in which direction does the ball experiences the force?
Downwards.
Upwards or downwards?
Downwards.
Downwards. So this downward force will essentially add up to the weight and give rise to a much bigger downward acceleration. So as long as the collision happens with the roof, there should exist a much higher downward acceleration with compared to the initial case. So what that can be? Uniform downward acceleration, and then as the ball hits the roof, an increased downward acceleration. So which one of these graphs show you that property?
D.
Sir, D.
D is the correct response, by the way. বুঝে গেছে কি?
Sir, if the ball was falling and then it hits the ground, then the acceleration would be positive. Like for the instance of the impact. Sir,
Then, sir, we would have to
দাঁড়ান,
omit
চিন্তা করছি। আবার কোশ্চেন আবার বলো।
if the ball was falling downwards, then would the graph be like C, or would it?
Well, one more question, interesting point, that in physics we don't essentially determine the positive direction based upon the initial velocity. We don't do that. We empirically or universally assume upward is positive, rightward is positive, and vice versa. Okay, so
Yeah.
but if you assume, let's say if you assume that the ball was dropped onto the ground, or it was thrown to the ground, and initial direction is positive.
But I mean, if it was downwards, then I mean, it would obviously. I mean, you don't have to consider the downwards to be positive. I mean, I'm just asking, like, if it was C.
Well, that's the point I'm trying to give you. That is that, in my opinion, if the ball ever have to rebound off the ground, C cannot be an answer. Come to think about this, C shows you that the acceleration was always negative, right? At one point you had a bit of a spike, but that spike did not even reach to the positive side of the graph. So it was always negative, which means the force that was experienced by the ball was always working towards the ground. At one point that force became a bit smaller, but it was always working towards the ground. So would there be any reason for the ball to undergo a rebound?
No, sir.
So it might as well hit the ground and get stuck there, period. Like let's say like an egg, or like a bowling ball dropped onto a piece of clay, something like that. So you might experience a small bit of less downward acceleration, but you will never have a case of rebound, because rebound হওয়ার জন্য কি লাগবে? ডাউনওয়ার্ড ভেলোসিটিটাকে 0 বানাইতে হবে, তারপর সেই ইলাস্টিক পোটেনশিয়াল এনার্জিকে আবার রিবাউন্ড করে তাকে উপরের দিকে শুট করতে হবে। So C is a possible case for an object dropped from a height, but it did not at all rebound. It hit the ground and stayed there, period. Does that make sense?
Sir. So for the rebound, the spike would be.
তাহলে কি কেস হতো?
যদি রিবাউন্ড করতে হতো তাহলে এসেনশিয়ালি আমাদের দরকার ছিল যেটা, যে রিবাউন্ড করতে হলে অবশ্যই এই জিনিসটা সিগনিফিকেন্টলি বড় হতে হতো, so that your upward acceleration would have been so high that the ball could actually come to rest and eventually be shot upwards. Then as it leaves off the ground, it would once again start experiencing the downward acceleration, which will also slow it down. But there has to have an acceleration even for a small amount of duration, but large enough, which would give the ball an upward velocity overcoming the downward velocity that it hit the ground with. That would have been highly required. বুঝাইতে পারছি?
Yes, sir.
So yeah, তারপর বলো।
Sir, when the ball collides with the ceiling, Newton's third law appears, right?
Yes.
So resultant force is 0.
I'm sorry.
Sir, if Newton's third law appears, then resultant force 0, right?
What does Newton's third law has to do with resultant forces?
Opposite forces equal in direct size and opposite in direction.
Newton's third law forces appears are only applicable on two different bodies, not on a single object. You can only do the resultant of equal and opposite forces as long as the forces work on a single object.
Oh, okay.
So resultant force is not at all anyhow related to third law. বুঝতে পারছি কেন?
Yes, sir.
আচ্ছা। Number 44. I like this question and I'm going to discuss this question in detail. Question পড়ো সবাই, কোশ্চেনের কারেক্ট আনসার বলো। ফুটিং করে শব্দ হলো কিসের? Go ahead, give it a read.
So the answer is A.
Oh man. The correct response for this question is A. Can everybody understand why?
Yes, sir.
It has to do
Yes,
with the
sir.
smooth slope and the smooth surface, but inelastic collision. So after the collision, the speed would be less, but it would cover the same amount of distance in the backward direction ZY, which is going to take a bit longer time. But ultimately, as it will start its journey along the YX direction, that deceleration would be the same as the acceleration for the XY direction. So the slope of this line and the slope of this line should be same, because the component of weight which is accelerating this ball in this direction will be the same component of weight that will be decelerating as the ball is going to start going upward. So these two deceleration values or these two gradients cannot be different. That's the point. Acha, now let me ask you these questions. How would you change the question for making this one the correct answer?
Buffer থাকতো একটা elastic buffer.
Elastic with the
Elastic collision.
Point Z টাকে।
হ্যাঁ, elastic হইতে হবে, beautiful. Then how do you change the question for C? How would you change the question to make the answer to C?
Collisionটায় অনেক এনার্জি চলে যাবে, এখানে একটা
স্লোপটাকে আরো স্টিপার করে ফেলবো after time being. After collision the slopes get steeper.
After the collision the slope gets steeper. Yeah, that can be a very good option. Is there anything else that you can do, or is there any other alternative to that? The solution that one of your classmates provided, that the difference between A and C is that this part, do you see that? What do you see over here? A much stronger deceleration. হ্যাঁ, এতে হচ্ছে গ্রেডিয়েন্ট গুলো সেম ছিল, বাট সি তে গ্রেডিয়েন্ট সেম না, মানে এখানে গ্রেডিয়েন্ট অনেক স্টিপ। তার মানে হচ্ছে as the ball is going to start going along YX, it should experience a much stronger deceleration. So that is possible to achieve if we just make this tilt a bit more. So আমরা যদি সারফেসটাকে আর একটু খাড়া করে দেই, আফটার দ্য কলিশন যদি আমরা সারফেসটাকে এরকম করে দেই, তাহলে আমরা ওটা খুব ইজিলি পাইতে পারবো। In that case we can very easily achieve that. That's an acceptable option. But is there anything else we can do?
যদি ফ্রিকশন বাড়ায় দেই,
so friction is a possible answer, but how would you word that? So think about the proper wording.
Only the slope has friction.
Only the slope has friction. Yes, that can be a correct answer. So if we say that this word is replaced with rough, Now you might wonder, what, how? Let me explain.
Sir,
Yes, I need to let you go.
sir, smooth মানে কি আমরা ধরে
হ্যাঁ, স্মুথ মানে হচ্ছে জিরো ফ্রিকশন।
আচ্ছা
Smooth মানে zero friction. Okay, so have a look at this question. So if I define this surface to be rough, one of the part that I really need you to understand, when the ball will be released, the weight component along this slope will work in this direction and the friction is going to work in that direction. Well, obviously the weight component is supposed to be bigger. That's why it is going to fall downwards with a constant acceleration and fall down. That acceleration is shown over here as the speeding up, which totally makes sense. Totally makes sense. But when the ball is going to start rise up from here in the upward direction, so after the rebound as the ball starts to go along y-x, in that case, the weight component is going to work backwards and the friction is also going to work backwards. So have a look. In this case, the weight component was working forward, the friction was working upward. You overcome the friction component using, you overcome the friction force using the weight component along this direction. But in this case, both the weight component and the friction force, both are working opposite to the motion. So essentially your resultant deceleration should be definitely get bigger. Do you understand that part?
Yes, sir.
For example, আমি যদি ভ্যালু দিয়ে বলি, মনে করো, let's say আমি ভ্যালু দিয়ে বলতেছি, let's say the weight component along this direction was 10 Newton and let's say the friction value is 2 Newton. So in this case, the resultant force as it falls downwards is supposed to be how much? 8 Newton. So you can see the acceleration relevant to 8 Newton force over here. Works. When the ball is gonna, after the rebound, the ball is gonna fall downwards, hit over here and rebound, and eventually it's gonna start go upwards along y-x. In that case, that 8 Newton frictional component, as the object is on this slope, that frictional component, let me draw that with green, that will also along this direction, that will have a value of 10 Newton. And the, sorry, frictional component will say, the gravity component. The component of gravity, that will also be 10 Newton. And the frictional component will also oppose the motion because now the ball is trying to go upwards. So friction is going to work downwards. So together these two forces are going to add up to give you a total backward force of how much? 12 Newton. So in this case, the acceleration was happening for 8 Newton, but in this case, the deceleration is happening because of 12 Newton. So do you understand this part? Because you're going to have a bigger force of deceleration, the deceleration will also be steeper. So এখানে আমাদের যতটুকু acceleration value হবে, এখানে deceleration magnitude তার থেকে বেশি হওয়া possible only if we say that this surface was not smooth, rather this surface was rough. So that could be another change that we can bring about. না বুঝলে কোশ্চেন করো। সবাই সবকিছু বুঝে ফেলছো? আচ্ছা ঠিক আছে, সমস্যা নাই। I've kept you longer than usual and I'm going to finish the class right now. I will pick up our next class from this point and we'll go forward and we'll then start solving the paper 2 worksheet. So এগুলোই তোমাদের homework থাকলো। Get busy with your worksheet and যারা পরে join করছো, you have YouTube lectures and other stuff to catch up. Thank you very much for your patience. We'll stop the class. Any further question about anyone? Hello?
Sir.
সব চুপ মেরে গেছে। Never mind. Bye.
Bye bye.
Bye, sir.